Alrighty, hi Addy, welcome to lesson number 93. And today's lesson is going to be great. I think you're really going to like it. It's short, it's to the point. We're going to talk about classifying triangles. You probably remember this from before. You've probably done it once before. So if you do remember it, then you'll recognize the names of these triangles: equilateral, isosceles, scalene. And this kid is raising his hand and saying, "You forgot Bermuda." Bermuda? Do you think he's talking about the Bermuda Triangle? Ha, that's silly. All right, so before we jump into the lesson, let's warm up with 28 improper fractions to simplify. So get out your 28 improper fractions, and I'll give you 5 minutes. Ready, set, go. I'm going to find some music. this song. This is the one from like Groundhog Day, isn't it? I'm going to stop you right there. That is interesting. That is the song I think that that guy from Groundhog Day learns to play. All right, anyway. Let's get back to the lesson. All right, the first thing we are going to do is some mental math. And we are going to watch this monster. I can't remember his name. Sully? No, that's the big hairy one. What's this guy's name? You tell me. Text me and let me know, okay? We're going to count up and down by 1/8 between 1/8 and 3. Here we go. Let's do 1/8, 1/4, 3/8, 1/2, 5/8, 3/4, 7/8, 1, 1 1/8, 1 1/4, 1 1/2. Oh, 1 3/8. Sorry, 1 1/2, 1 5/8, 1 3/4, 1 7/8, 2, 2 1/8, 2 1/4, 2 3/8, 2 1/2, 2 5/8, 2 3/4, 2 7/8, 3. Now we have to count down. So let's start with 3, 2 7/8, 2 3/4, 2 5/8, 2 1/2, 2 3/8, 2 1/4, 2 1/8, and then 2, 1 7/8, 1 3/4, 1 5/8, 1 1/2, 1 3/8, 1 1/4, 1 1/8, 1, 7/8, 3/4, 5/8, 1/2, 3/8, 1/4, 1/8. Okay, I think I messed up at least one time in there, but hopefully you got through it. Okay, we're going to see some really cute pictures of baby kittens while we do mental math. What is 40 times 60? Remember, do the numbers first. 24, add 2 zeros. 2,400. Okay. B, what is 234 minus 50? Oh, tricky, tricky. What is 25% of 24? And we're going to think of this number as 1/4. So what is 1/4 of 24? Or divide it by 4. D, what is 599 plus 247? Okay. E, what is 1.2 divided by 100? Is this number going to get bigger or smaller? We're dividing, so it's going to get smaller. You got it. F, what is 30 times 25? I would just think of this as a quarter. If you have 3/4, it's going to be 75. Don't forget to add that 0. G, what is 8 times 9? That's the number we're starting with. Then we're going to add 3. Divide by 3. Take the square root of that number. Multiply by 6. Add 3. Divide by 3. Subtract 10. What do you get? Ooh, that's tricky. Problem solving. Oh, look at that cute puppy chewing on that tennis ball, huh? Problem solving. We are going to compare the following. So we don't actually have to figure this out. We just have to compare. So we're either going to put equal than, greater than, or less than. Then describe how you performed the comparison. So this is 54. This is 6 point something times 9 point something. So what is 6 times 9? And then there's a little extra something after the 6, and there's a little extra something after the 9. So is that number going to be greater than, less than, or equal to 54? I'll let you figure it out. And I'll jump into the new concept. Hang in there. We're almost, I know it feels like we're just getting started, but this is not a long lesson, so we're actually almost there. We're going to talk about triangles. Now, every 3-sided polygon is a triangle. You can't draw 3 straight lines and have it not be a triangle. It's always going to be some sort of triangle. Even that, yes. And the triangles can be classified. And they're either going to be classified by their side or their angles. We're going to talk about sides first. Here's the sides. So take a look at this graph that you have. The first one is called the equilateral triangle. Equilateral means all 3 sides are equal. So if I measure this, this measures the same length as this, and that measures the same length as that. When I make those little hash lines, that means they measure to be the same. This is the same as this is the same as this. This to me looks like a perfect tent. If you're going out camping and you make a perfect tent, it's going to look like an equilateral triangle. The other thing that's equal about this triangle is the angles. 1, 2, 3 angles. If you measured them, they would be the same. It's a perfect tent, perfect triangle, equal, equal, equal. All right, next triangle, isosceles. Isosceles triangle. I saw some beautiful houses that you made in Minecraft, and this looks like the roof on the beautiful house. Like, see, it can be a house. There's a house. I saw a beautiful house, and that beautiful house had a beautiful roof. And if it's a beautiful roof of a house, it looks like this. What does this mean? 2 sides are equal. So this is the same as this, it's perfectly symmetrical. But this one's going to be longer. Okay, so it could be, well, let's see. This is the same as this. And it turns out they're going to have 2 angles that are the same. Can you guess which ones? I would say this one and this one. And so those 2 angles are the same. Those 2 sides are the same, but this side is different. So that one's extra long. It doesn't have to exactly look like the roof of a house. It could be going like, well, let me see. It could be going like this. And then this. And then this. If I drew it good, these sides would be the same. These would be, and it could be facing any direction. It doesn't matter. It could be this, right? And that would mean that these sides are equal. These angles are equal. Cool, huh? All right, the last one is the scalene triangle. Scalene. Now, the SC reminds me like, if I were making a tent, I'd probably totally screw it up. Scalene is a screw-up tent. It doesn't look like a tent at all. It looks like if I tried to make a tent, that's what it would look like. Turns out this side is different from this side, and that is different from this side. All of the sides are different lengths. And when you have them all different lengths, that is a really screwed up tent, so that's a scalene triangle. 3 unequal sides. And guess what else is unequal? All the angles are different. And let's see. I'll show you how you indicate different angles. Let me zoom in. This would be one angle. This would be a different angle. This would be a different angle. They're all different. See? Cool. All right. Now, triangles can also be classified according to their angles. So, what is this? An acute triangle. It's so cute. Not because it has like cute eyes and a smile, but I guess that's kind of cute. I don't know. It means all the angles are acute. What does that mean? All the angles are less than 90 degrees. So they're not big fat angles. They're cute little tiny angles. So this is cute. This is acute. This is acute. So they don't have to be the same. They just have to be less than 90. Okay? All right, let's look at the next triangle. This is a right triangle. A right triangle has one angle that is a right angle. So that one. So see the square? That means that this side is totally perpendicular, straight up and down when you compare it to this side. And when you have those perpendicular lines, that means you're going to get a 90-degree angle. It doesn't matter what the other angles are. They're probably going to be acute. Like they would have to be. But if one of the angles is a right angle, that makes it a right triangle. Okay? Next one. And fun fact, this also looks like a scalene triangle because all those sides look like different lengths. What about an obtuse triangle? If you look at the angles, if one angle is ginormous, bigger than 90, then it's obtuse. Remember, obtuse seems like the word obese. So if you have one really fat angle, fatter than 90 degrees, then you can say this is an obtuse triangle. Okay? The other angles are going to be acute. So those ones are acute. But if it has one angle that's really big, that's still going to be an obtuse triangle. All right. So let's see. What else do I need to tell you? Each angle of an equilateral triangle. Oh, let's go back to the equilateral triangle for a moment. An equilateral triangle means it is a perfect tent. Let's see if I can draw a perfect triangle. Nope, I don't think I can. But if this were a perfect triangle, all the sides would be equal length and all the angles would be equal. Now you're going to find out later that when you add up all the angles of a triangle, they add up to angle 1 plus angle 2 plus angle 3 is always 180. They don't tell you that in your lesson, but that is a truth you're going to learn later on. And so if they're all equal, then all the angles of an equilateral triangle have to be 60 degrees because 60 plus 60 plus 60 is 180. So this angle right here, if you were to measure it with like a protractor, you would get 60. If you were to measure this one with a protractor, you'd get 60. And if you measure this one with a protractor, you'd get 60. As long as I made my equilateral triangle perfect. Now, what about an isosceles triangle? Remember an isosceles triangle? It looks like the top of a house. Like you've got this, and you've got this side. Now, when we're talking about angles, this could be 90 degrees, and so an isosceles triangle could be a right triangle. I'll just put right triangle, okay? But it could also be obtuse because I could erase this and make this like a flatter roof. So like if I make it like this, right? Now that angle is huge and it's still the roof of a house, and so it's still an isosceles triangle. But now this angle is super fat, so it would also be an obtuse triangle. So an isosceles triangle could be a right triangle, an obtuse triangle. Could it also be an acute triangle? Sure, it would just be a skinny, tall roof. This is isosceles because only two sides are the same, but it's also acute because that's a cute little roof. No, because it's acute because all the angles are small, less than 90. Okay, what about a scalene triangle? A scalene triangle, remember that all the sides are different. So this could be really long, this could be short, this could be somewhere in the middle. This is a scalene. Could it also be an acute triangle? Sure. Yeah, why not? I would just take this one and move it, I don't know, move it something like that. So it's less than 90. And then erase some of this. Yeah, there you go. Acute. This one's acute. Could you make it an obtuse triangle? Oh, sure. Why not? Just take this one. Well, okay. Just take this line and make it a fat angle. Stretch this one out. Whoops. It doesn't look straight. I did a bad job at that. But that's okay, because I think you get the idea. This is a scalene triangle, but it's obtuse. Scalene means all the sides are different. I put it so it's hard to tell because this looks like this side, but if it's different and if they're all different, then it's an obtuse triangle and also a scalene triangle. A scalene triangle could also be a right triangle, because a right triangle just means that you have a right angle. So here I made a right angle, but this one's short, this one's longer, and this is going to be the longest one of all. So that's scalene. It's all screwed up because all the sides are different. But it's also a right triangle because of that angle. Cool. Guess what, Addy? Have you had enough of triangles? You're going to have triangles on the brain, just like this kitty cat. All right. Have a great time doing your math today, Addy. Love ya. Bye.